Hello guys, welcome to H2O, the A to Z of chemistry. I'm Dr. Ritu Johar, your educator for this course, and I hope you're enjoying this course with me. So good morning guys. Today we begin with lecture 11 from the course, but make sure you watch the previous ones before viewing this one. In the last lecture, we learned what is the hardness of water. So I hope the whole concept that is clear to you, that hard water is going to be the one which does not produce lather with soap, whereas soft water, it produces easily that lather. And why is the water hard? It is because of the presence of the calcium and magnesium salts in it. Which type of salts? The bicarbonates, the chlorides and the sulfates of calcium and magnesium, they cause the water to be hard. Also in the last lecture, you learned that there are going to be two types of hardness, the temporary hardness and the permanent hardness. Temporary because of the bicarbonates and permanent because of the chlorides and the sulfates of the calcium and magnesium. Now, also what you learned in the last lecture was how we are going to remove these two types of hardness. So what we are going to do? Well, we are going to remove the temporary hardness by boiling or by the Clark's method, whereas the permanent hardness by various other methods like the soda lime process, the ion exchange method, the Calgon process and so on. So now we are going to move further on in this discussion on the hardness of water. Today we will be learning the degree of hardness of water. So what do we mean by the degree of hardness of water is that we have to still quantify how much hard the water is. Is it small amount of hardness or it is going to be a large amount of hardness? So that is going to be given to us by the degree of hardness of water, and then we will be taking up a certain numericals based upon the concept. So I hope you are excited. So let us begin with our learning today. So what is the degree of hardness of water? Well, the number of parts of calcium carbonate or magnesium carbonate equivalent to the various calcium and magnesium salts present in million parts, that is 10 per 6 parts of water by mass, is called as the degree of hardness, and we express it in parts per million, that is ppm. So the formula for degree of hardness, this is mass of calcium carbonate over mass of water into 10 per 6 ppm. So what this means is that whatever may be the hardness causing salt, it may be calcium bicarbonate, it may be calcium sulfate, it may be calcium chloride, we will be finding the equivalent mass of calcium carbonate for those salts, and then we will be finding out the hardness of water. So let us understand this better with the help of a few numericals. Now, from the definition itself of the degree of hardness, you must have come to know that what is going to be important for us is to find out the number of equivalents of calcium or magnesium carbonate, which is going to be equal to the number of equivalents of the various hardness causing salts. So what is going to be helpful to you in these numerical problems is going to be the equivalent concept, and therefore the equivalent concept that should be clear to you. In case you have any doubts, there are two lectures from us in the course on some basic concepts of chemistry. I will be putting up the link in the description box below, so you can just watch those lectures to have a better understanding of the equivalent concept. We have put it in such a way that is going to be very simple for you to understand. Generally, the students that do fear the equivalent concept, so if you are one of those, well, you will really be very glad after you have finished those lectures, right? But now I'm just quickly putting out all the formulas that are going to be required to do these numericals today. Fine. So we have the equivalent weight, which is going to be equal to molecular mass over the valency factor, that is the Z factor. So equivalent weight, we will be writing this in short as EW. The molecular mass as MW, that is the molecular weight, divided by the valency factor, that is Z. Generally, we represent the molecular mass as capital M only, but I have just put it over here as MW just to differentiate it from the equivalent weight that we will be representing as EW. Fine. So the way you want to write it, that is your choice. I do not say anything that you have to write it this way only. Fine. So now what you know is that the number of moles, this is going to be equal to the mass of the sample divided by the molecular mass. So this is going to be small w divided by mw. And the number of equivalents, this is equal to the mass of the sample over equivalent mass, and the equivalent mass, so this you are going to represent as W over EW. Now the number of equivalents, you can replace the equivalent mass from this formula of the equivalent mass, right? So what we will be writing is that equivalent mass is going to be equal to molecular mass over the Z factor. So what we will be getting, the number of equivalents is going to be equal to the mass of the sample W divided by the molar mass into the Z factor. So W by MW is nothing but the number of moles. So we will be writing this as number of moles into the Z factor. So what we will be getting, in short, the number of equivalents is equal to N into Z factor. So these are the formulas that we will be utilizing in the numerical problem. So I've just now put them over here. But for a thorough understanding of the whole concept, you can watch those lectures from the course on some basic concepts. That is going to be really helpful for you people. Fine. So coming up on your screen, the first question for today, if hardness of a water sample, this is 200 ppm, then select the incorrect statement or statements. The choices are mass ratio of calcium carbonate to water, this is 0.002 by 100. Mole ratio of calcium carbonate to water, this is 3.6 into 10 power minus 5. Mass of calcium carbonate present in hard water, this is zero point 0.2 gram per liter. And 1 milliequivalent of calcium carbonate is present in 1 kg of hard water. So let us see what all information can the hardness of water sample imply. Right now, what is hardness of water? What you have just now learned is the formula is that mass of calcium carbonate over mass of water into 10 power 6 ppm. This is going to be the hardness of water. Now the first choice is to find out the mass ratio of calcium carbonate to water. So what do we want? We want the mass of calcium carbonate and we want the mass of water. Can we get this from the 200 ppm value? So what 200 ppm means is the 200 gram of calcium carbonate, this is present in 10 power 6 gram of water. So the mass of calcium carbonate is 200 gram. The mass of water is 10 power 6 gram. Just find out the ratio of these two. So what you will be getting the value is 2 into 10 power minus 4. Now if you look at the A choice, what is this going to be? Well, this is going to be 2 into 10 power minus 3 divided by 100, or you can say it is going to be 2 into 10 power minus 3 into 10 power minus 2. So this is going to be 2 into 10 power minus 5. Here what we have found out is that the mass ratio is 2 into 10 power minus 4. So A statement is going to be incorrect, right? Next, let us see what is the second choice. Now the second choice asks us to find us the mole ratio of calcium carbonate to water. Again, this is going to be very simple. You know the masses of calcium carbonate and water also. What you have to do is just find the moles of that. So the moles of calcium carbonate, they are going to be the mass divided by the molar mass, so 200 divided by 100, and for water it is going to be 10 power 6 divided by 80. So the value that is going to come up is going to be 3.6 into 10 power minus 5, and here also in the choice this is given to us to be correct. So the B choice is going to be correct and the A choice is going to be incorrect. So now let us move on to the third choice. So now the C option is to check whether the mass of calcium carbonate present in hard water, this is 0.2 gram per liter or not. So how are we going to proceed? You have to look at this value. What is given to us is the mass of calcium carbonate per liter of the solution. So what we require is the mass of calcium carbonate. What we require is the volume of water. Right? So what we have information given to us is 200 ppm of calcium carbonate, which means that the mass of water is 10 power 6 gram and mass of calcium carbonate is 200 grams. We are given the mass of calcium carbonate, but we are not given the volume of water. We are given the mass of water. How will we find the volume? So you all know that the density of water is 1 gram per centimeter cube or 1 gram per ml. So density is mass by volume. Volume is going to be mass by density. So volume is going to be 10 power 6 ml, which is going to be equal to 1000 liters. So we have the mass of calcium carbonate. We have the volume of the water given to us. So what are we going to do? Well, mass of calcium carbonate in 1000 liter of water is 200 grams. What we require is per liter, that means per 1 liter. So mass of calcium carbonate in 1 liter is going to be 200 by 1000. This will come up to 0.2 gram per liter. So we have found out the mass of calcium carbonate present in hard water. This is 0.2 gram per liter. The choice is also the same. So the C option is going to be correct. Now the fourth choice is that we have to find out 1 milli equivalent of calcium carbonate, whether this is present in 1 kg of hard water. So here you have to have an understanding of the equivalent concept that we've already revised. So let us proceed now. So we know that the mass of calcium carbonate is 200 grams in 10 power 6 gram of water, which is what 200 ppm means. Now from this mass of calcium carbonate, can we find out the number of moles of calcium carbonate? Yes, we can. We have to simply divide this mass by the molar mass. So 200 by 100 moles is what we will be getting of calcium carbonate in 10 power 6 grams or 10 power 3 kg of water, that is 1000 kg. If it is 1000 kg, you are getting 2 moles. So in 1 kg, you will be getting how many moles? It will be 2 millimoles of calcium carbonate. Now, just before we started the numericals, what did we see as a relationship between the number of moles and number of equivalents? We had studied that the number of equivalents, this is going to be equal to Z factor into the number of moles. So the Z factor we know for calcium carbonate is going to be 2 and the number of moles is 2 millimoles. So the number of equivalents is going to come up to 2 into 2, that is 4. So it is not going to be 1 milli equivalent of calcium carbonate in 1 kg. It is going to be 4 milli equivalents in 1 kg. So this option is going to be incorrect. So option number A and option number D, they are incorrect. And now I hope you have developed an understanding what type of questions they can be based on the hardness of water. So you are getting a good feel. Now let us move to the second question. Question is 1 liter of a sample of hard water. This contains 4.44 milligram of calcium chloride and 1.9 milligram of magnesium chloride. What is the total hardness in terms of the ppm of calcium carbonate? And the choices they are given to us is 2 ppm, 3 ppm, 4 ppm and 6 ppm. So how are we going to proceed with this question? What do we have to find out? Let us see that first. We have to find out the total hardness in terms of the ppm of calcium carbonate. So what is the formula that we learned for hardness? Well, it is mass of calcium carbonate over mass of hard water into 10 power 6 ppm. This will give us the hardness of water. So what do we require? We require the mass of calcium carbonate. We require the mass of water. Is that given to us in the question? I cannot see that. So let me read the question back again. So this says that 1 liter of a sample of hard water. Wait a minute. What is given to us is 1 liter of a sample of hard water, which means that what is given to us is the volume of water. Can we find the mass of water from the volume? Yes, we can. Mass of water, this will be equal to volume into density. So we will get the mass of water to be equal to 1000 ml, that is 1 liter of water, into 1 gram per ml, that is the density. We will be getting mass to be equal to 1000 gram or 1 kilogram of water. So one thing we have found out, mass of water. What is left behind? Finding the mass of calcium carbonate. Now what to do? Well, it is not given to us. How are we going to find out? So here what you have to understand is that what is calcium chloride and magnesium chloride? These are permanent hardness causing salts. Can we convert them into calcium carbonate? Just remember what you did in the last lecture. We said that when calcium chloride, this is going to react with washing soda, what we will be getting is calcium carbonate. I hope you remember. Let us look back at the reaction. Calcium chloride, when this reacts with washing soda, that is sodium carbonate, we will be getting calcium carbonate and NaCl. This is a white precipitate. This will settle down. We will be removing this by filtration and the water is going to be free from this calcium chloride. Right? So what this means now and looking at the reaction is that I can apply the mole concept, and I can find out many things now. So 1 mole of calcium chloride is going to give me 1 mole of calcium carbonate, isn't it so? So what this means is that if I have the molar mass, it is going to be 111 gram for calcium chloride, 100 gram for calcium carbonate. So from 111 gram of calcium chloride, I am going to get 100 grams of calcium carbonate. Right? What is given to me is 4.44 milligram of calcium chloride. So this means that applying the unitary method, I will be getting the mass of calcium carbonate, which is going to be equal to 4.44 milligram of calcium chloride. So this will be 100 by 111 into 4.44. This will come up to 3.96 milligram, which will be approximately 4 milligram of calcium carbonate. This is one way of doing it by using the mole concept. We can use the equivalent concept also over here, where this is meaning that the number of equivalents of calcium chloride and calcium carbonate, they will be the same in the reaction, right? So the number of equivalents of calcium chloride, this will be equal to the weight of calcium chloride over the equivalent weight of calcium chloride. This is going to be equal to the number of equivalents of calcium carbonate. So how are we going to get the number of equivalents of calcium carbonate? Weight of calcium carbonate over the equivalent weight of calcium carbonate. So put down the values. What you will be getting is that the weight of calcium chloride is given to us as 4.44, right? Equivalent weight is going to be molar mass by Z, right? So this is going to be 111 divided by 2. This will go on top, so this will be multiplied by 2. Similarly, for calcium carbonate, what we have to find out is the weight. The equivalent weight is going to be molar mass divided by Z, so it will be 100 divided by 2, which will go on the in the numerator, so this will be multiplied by 2. So this is going to cancel out, this is going to cancel out. What you will be getting, the value of X, or the weight of calcium chloride, is going to be again approximately 4 milligram per calcium carbonate. So this is what we have as the equivalent concept. Now for the equivalent concept, the advantage is that you need not know the reaction. You can just say that in the reaction, 1 equivalent of calcium chloride is going to give us 1 equivalent of calcium carbonate, right? And because both of them, they are calcium, so we could have even omitted this 2 over here. We could have simply written the molar mass as well and proceeded forward. I have written this 2 so that you have a proper understanding that you have to find out the number of equivalents over here, how we are going to do that. So I hope now this is clear to you that we can use either the mole concept, we can use the equivalent concept. Using the equivalent concept is better because from here you need not know the reactions also. Okay, so this is what we have as far as now calcium carbonate with respect to calcium chloride. Similarly, what we are going to do is for magnesium chloride as well. So next we have to see how we are going to convert magnesium chloride into calcium carbonate, because the total hardness we wanted in terms of calcium carbonate hardness only. So we are going to use now 2 steps over here, 2 reactions from where we will be getting calcium carbonate from magnesium chloride. So magnesium chloride, on reacting with calcium hydroxide, which is lime, we will be getting magnesium hydroxide and calcium chloride. Calcium chloride, you've just now seen that when this is going to react with washing soda, you will be getting calcium carbonate or NaCl. So washing soda, this is also called as soda ash. So for converting magnesium chloride into calcium carbonate, you require 2 ingredients. One is going to be lime and the other is soda. So this is called as soda lime process that you studied in the last lecture. We can write this reactions in another way also, that magnesium chloride, this will react with sodium carbonate first. What you will be getting is magnesium carbonate. Magnesium carbonate on reaction with calcium hydroxide will give us magnesium hydroxide and calcium carbonate. But essentially you are using the same 2 ingredients to convert magnesium chloride to calcium carbonate. So what are we getting? 1 mole of magnesium chloride giving us 1 mole of calcium carbonate. So rest is going to be easy. Apply the mole concept and get the answer. So 95 gram of magnesium chloride, that is 1 mole of magnesium chloride, is going to give us 1 mole of calcium carbonate. So this will be equal to 100 grams. What is given to us in the question is 1.9 milligram of magnesium chloride. So this is going to be equivalent to 100 divided by 95 into 1.9 milligram of calcium carbonate. This is going to come equal to 2 milligram of calcium carbonate. Now, if you apply the equivalent concept, this is going to be easy, because then you do not have to think about what the reactions are going to be to get calcium carbonate from magnesium chloride. It is going to be one equivalent of magnesium chloride, which is going to give us one equivalent of calcium carbonate. So let us write the equivalent concept. The number of equivalents in both the cases, they will be the same. Therefore, weight of magnesium chloride over equivalent weight of magnesium chloride is going to be equal to the weight of calcium carbonate divided by the equivalent weight of calcium carbonate. Put down the values, you will be getting the value of X, that is the weight of calcium carbonate, to be equal to 2 milligram of calcium carbonate. This is what you had found from the mole concept. But here you had to think of so many reactions, which I hope you do not like. So if you learn the equivalent concept, this is going to be really very easy for you. Now we have found out calcium carbonate, which we got from calcium chloride, and we have got from magnesium chloride. So add up the two, you will be getting the total mass of calcium hydroxide to be equal to 4 milligram plus 2 milligram, that is 6 milligram. Write it in terms of grams, because the total hardness we are going to express it in terms of grams. Okay, so it is going to be 6 into 10 power minus 3 grams. And the hardness of water, this is going to be 6 into 10 power minus 3 grams of calcium carbonate. Over you had was 1 kg of water, so this will be 10 power 3 grams of water into 10 power 6. So the answer that you will get is 6 ppm. Right, so I hope you are understanding how are you going to use the mole concept or the equivalent concept to do your numericals. Now the third question is that 10 liters of hard water, this requires 5.6 gram of lime. For removing the hardness, find the temporary hardness in terms of ppm of calcium carbonate if it is due to calcium salts only. So the choices they are given to us is 1000, 2000, 100 and 1. So how are we going to proceed? Again, first of all, what do we have to find out? We have to find out hardness in the ppm of calcium carbonate, but this is because of now the temporary hardness. Okay, so temporary hardness is because of what? It is because of the calcium and magnesium bicarbonate. But again, it is given to us that this hardness is because of calcium salts only. So the hardness causing salt is going to be calcium bicarbonate. Calcium bicarbonate is going to react with lime to give us calcium carbonate and water. Right, now one thing more, please remember, here we have written calcium oxide. What you learned in the previous lecture was that we use slaked lime. How do we get slaked lime? We get slaked lime by the reaction of calcium oxide, that is quicklime, with water. Fine. So what are we adding is actually quicklime, that is calcium oxide. So here also we are adding 5.6 gram of lime, which is going to react with bicarbonate to give us calcium carbonate and water. Okay, so I hope this is clear that we have quicklime which we add into water when we get a solution of lime, that is lime water, or a suspension of lime, that is going to be slaked lime. When it is given over here 5.6 gram of lime, this is meaning that we are adding quicklime or calcium oxide rather than writing over here calcium hydroxide. So please do write calcium oxide. Now we have calcium bicarbonate 1 mole reacting with calcium oxide 1 mole. So it is going to be 162 gram reacting with 56 gram. What we have is 5.6 gram. So the bicarbonate, which is going to be equivalent to 5.6 gram of calcium oxide, is going to be 16.2 gram. Fine. So 162 gram of calcium bicarbonate is equivalent to 100 gram of calcium carbonate. 16.2 gram of calcium bicarbonate will be equal to 10 gram of calcium carbonate, and therefore the hardness of water, this is going to be equal to mass of calcium carbonate over mass of water into 10 power 6. So mass of calcium carbonate is 10 gram, mass of water is what you will be finding from the 10 liters of water. So 10 liters is going to be equivalent to 10 kg. I hope now this is clear to you. So what we have is 10 over 10 to the power 4 into 10 power 6. So what the answer is going to be 1000 ppm. So we have 1000 ppm of hardness in terms of calcium carbonate because of this temporary hardness causing salt, that is calcium bicarbonate. Now the next question is that 1 liter of pond water, this contains 20 milligram of calcium ions and 12 milligram of magnesium ions. What is the volume of a 2 normal sodium carbonate solution required to soften 5000 liters of pond water? So how are we going to do this? Well, we now know that calcium ions and magnesium ions, they are the hardness causing salts, and sodium carbonate solution, this is going to soften that hard water. How is it going to do that? Well, it is going to react with calcium ions, it is going to react with magnesium ions. What we will be getting is calcium carbonate, what we will be getting is magnesium carbonate, right? And both these are going to form white precipitates, and this can be filtered out, and hence the water is going to be free from the hardness. Perfectly fine. So now let us see how we are going to proceed as far as the numerical is concerned. So calcium ions on reacting with sodium carbonate is going to form calcium carbonate and sodium ions. So this means that the number of milli equivalents of calcium ions, this is going to be equal to the milli equivalents of sodium carbonate. Perfectly fine. Similarly, we have magnesium ions reacting with sodium carbonate to form magnesium carbonate and sodium ions. So again, the milli equivalence of magnesium ions, this is going to be equal to the milli equivalence of sodium carbonate. Now, what we have is that the total number of milli equivalents that are going to be required, this is going to be equal to the sum total of the milli equivalents of the calcium ions and the magnesium ions, right? So the milli equivalents of sodium carbonate, which is going to be required, is going to be equal to the sum total of these two. So we are going to write down now this. What we are given is that we have a 2 normal sodium carbonate solution. So 2 normal sodium carbonate solution, multiply this by the volume, you will be getting the number of equivalents for sodium carbonate. And for calcium and magnesium ions, the mass of the calcium ions divided by the equivalent mass of calcium ions, the mass of magnesium ions divided by the equivalent mass of magnesium ions, this is going to give us the milli equivalence of the calcium ions and the magnesium ions. Okay, so let us put down these values. So what we have is, for sodium carbonate, 2 normal, so 2 multiplied by the volume, this will be giving us the milli equivalence of sodium carbonate. For calcium ions, it we have is 20 milligram of calcium ions. So 20 divided by 20, which is the equivalent mass of calcium, right? 40 divided by 2. And then we have magnesium. So magnesium is 12 milligram divided by 12. Again, the equivalent mass of magnesium, 24 divided by 2. So what we get this is as 1 plus 1 is 2. So 2 is going to be equal to V plus 2. So the volume is going to be 1 ml for 1 liter of the pond water. Right? So we have 1 liter sodium carbonate requirement for 1 liter of the pond water, and what we have is 5000 liters of the pond water to be treated. So therefore, for 5000 liter of the pond water, we will be requiring how much? 5000 ml or 5 liter of the sodium carbonate solution, that is 2 normal. I hope this is clear that the calcium ions and the sodium carbonate ions, they are forming calcium carbonate. Magnesium ions and sodium carbonate, they are forming magnesium carbonate. The number of milli equivalents of calcium ions is going to be equal to that of sodium carbonate ions. Similarly, magnesium ions will be equal to that of the sodium carbonate ions. And the total number of milli equivalents of sodium carbonate that are required is going to be equal to that of the sum of calcium ion and magnesium ions. So for sodium carbonate, we are given 2 normal solutions. So multiply this by the volume, you will be getting this. For the milli equivalents of calcium ions and magnesium ions, the mass divided by the equivalent mass. So this is how you are going to get the solution, right? I hope this is clear, and you now can do any question related to the hardness of water. Now, in case you feel still any doubt, please watch the lecture again. Practice more questions and then see if you are able to handle. In case you are still having any difficulty, please feel free, put that in the comment section, or you can email them to us. The email ID is always written on the last slide of the lecture. So this is as far as the learning is concerned. So obviously there are going to be now the lecture review questions. So now the lecture review questions, there are going to be two questions. The first question, this is from the JEE Mains January 2020 examination, and the other, this is from the JEE Mains January 2019 examination. So I hope you can now understand why I have taken a complete separate lecture for dealing with the numericals based on the degree of hardness, because two questions coming in two consecutive years is something making this topic very important for you people. I hope you have now got it. So now please what you can do is that pause the video over here, solve these questions and post your answer in the comment section. Only after that, please do follow the rest of the lecture as well, because for this lecture, I am solving the questions in this lecture only. I'm not asking you to post in the answers only, then I will be giving the answers to the question. But well, I'm going to solve these for you people so that you have a thorough understanding of this topic. It is very important, right? So let us move on to the discussion once you have finished solving the questions yourself. Please do watch it only after you have done that. So now that you have solved the questions, let us quickly discuss them. Determine the degree of hardness in terms of ppm of calcium carbonate of 10 power minus 3 molar magnesium sulfate solution. The question asked in JEE Mains January 2020, a integer type question. So we are given 10 power minus 3 molar magnesium sulfate, which means 10 power minus 3 moles per liter, which means we have 10 power minus 3 moles of magnesium sulfate and 1 liter of water. So what are we going to do is, from the number of moles of magnesium sulfate, we will be finding the mass of magnesium sulfate. So the number of moles is equal to mass over molar mass. What we will be having is that 10 power minus 3, the number of moles of magnesium sulfate will be equal to mass of magnesium sulfate over 120, that is the molar mass of magnesium sulfate. So from this you will get the mass of magnesium sulfate to be 120 into 10 power minus 3 grams. The next we are given is 1 liter of water, so we will be converting it into mass rather than volume. So volume into density, what you are going to get is the mass equal to 1 kg. Perfectly fine. So this is something that we have been doing, so this should be very quick now. Now what we have is the mass of water with us. We have mass of magnesium sulfate, but to find the hardness, we need the mass of calcium carbonate. So how are we going to find it? By equating calcium carbonate equivalents to magnesium carbonate equivalents. So we will be having the weight of magnesium sulfate over the equivalent weight of magnesium sulfate, giving us the number of equivalents of magnesium sulfate. This is going to be equal to the number of equivalents of calcium carbonate, so that is the weight over equivalent weight. So quickly put down the values. What you will be getting is that the mass of calcium carbonate is just been written the opposite side. So this is mass of calcium carbonate divided by the molar mass of calcium carbonate, that is 100, multiplied by the Z factor, that is 2. This is going to be equal to the weight of magnesium sulfate, that is 120 into 10 power minus 3 over 120, the molar mass, into 2. Again the Z factor going to be the same. You write it or not, you should be able to identify that you have to write that Z factor. Fine. So now what we get, the mass of calcium carbonate, this will come up to 10 power minus 1 gram or 0.1 gram. So the mass of calcium carbonate we have found out to be 0.1 gram, and mass of water, this is 1 kg, that is 1000 gram, and we have to find the hardness of water. So mass of calcium carbonate over mass of water into 10 power 6. So putting the values, what you will be getting the hardness of water, this is will be equal to 100 ppm. So the answer, this was an integer type question. This was simple enough after having done so many questions, and I hope you have all got it correct. So please do put up a thumbs up if you've got the right answer. So the next question is that 100 ml of water sample, this contains 0.81 gram of calcium bicarbonate and 0.073 grams of magnesium bicarbonate. The hardness of the sample expressed in terms of the equivalence of calcium carbonate is: molar mass of calcium bicarbonate is 162, molar mass of magnesium bicarbonate is 146. The choices, they are given to you as 10,000 ppm, 1,000, 5,000 and 100 ppm. JEE Mains January 2019. So this should should not at all be difficult for you people. So now you all know that the number of equivalents of calcium carbonate is going to be equal to the sum total of the number of equivalents of calcium bicarbonate and that of magnesium bicarbonate, right? So just put down the values now. What you will be getting the value of W, that is the mass of calcium carbonate. This will come up to 1. I hope I do not have to explain you this again. I have been putting it in detail everything. So the weight of calcium carbonate, this is going to come as 1 gram. And the volume of water, this is given to us as 100 ml. So this is going to be equal to the mass of water to be 100 grams. So the hardness of water, now this is going to, the hardness of the water sample, now this is going to be 1, that is the mass of calcium carbonate, divided by 100 the mass of water into 10 power 6. So this we will be getting as 10,000 ppm. So again, I hope you all have been able to do this. We have done it really fast as far as this question is concerned, because we've already discussed each and everything. So I hope again this is going to be a thumbs up from your side as well, that you have got the answer correct. So this would be all for this lecture. The next lecture, we are going to start with a discussion on the last hydrogen compound, that is going to be hydrogen peroxide. Again, it is going to be very important. You are going to get many questions from the previous year examinations on hydrogen peroxide. So not the lectures to be missed. So please do subscribe to our channel, that is H2O Chemistry. Also do click on the bell icon so that you get a notification the moment we put up the next lecture for you. All your doubts, they are most welcome. Please mail them us to at h2ochemistry@gmail.com. You can also join us on the Facebook page of the channel, that is going to be by the same name, that is H2O Chemistry. Right? So see you again. Have a nice day. God bless you. Bye bye.